Hello, good morning, good afternoon, good evening, and welcome to another exciting session of Insights with upGrad. And with us, we have a very special guest today. More about him in a while. I am allowing more and more people to join this session. Hello, good morning, good afternoon, good evening. We know you're joining in from all parts of the world. So we've got to wish you in all the three greetings. And put a hi in the chat box and let us know which country you're from. All right, two quick rules for the session. For any questions you have for Martin to pick up at the end of this session, please use the Q&A box. I will be picking questions up from there. For any disturbances in audio video quality that you have, use the chat box. For any inputs that Martin wants to take from you during his session, use the chat box for making this session more engaging. All right, those were the two quick rules. Now, moving on to trying to understand a little bit more about why you're here. Let us know what's your current work experience and what's the outcome you're expecting from today's session. This will help Martin understand if he has to go really slow on some aspects of his topic, or he can skip over some parts and understand that you guys have been there, done that. All right, I can see about 40% of you have voted, waiting for the rest of you to just punch in those two keys. I hope you can see the live results, Martin.
I see the results, yeah. Thank you.
All right. So this, today it looks like a very, very balanced crowd. We've got like about 20% in each of these segments, which is so interesting. Wow. And most of them are trying to understand if they can transition their career in this domain. So your topic is definitely going to help them understand and answer that question. All right, that said, let me introduce our very special guest for today's session. We've got with us Martin Musiol, who is managing leading data scientist at IBM. He is a member of the Technical Expert Council at IBM, is a data scientist coach and mentor, and is the founder of GenerativeAI.net. He is a keynote speaker on various events and the co-founder of Story Beep, a natural language processing company. And that is what makes him want to talk about today's topic, which is NLP, natural language processing for beginners. I hand it over to you from here, Martin.
Thank you. Thank you very much, Meta. I'm very excited to be here. And also welcome to everyone from all over the world. I see India, Mysore, South Africa, Vietnam. So yeah, we are scattered around the world. Very exciting and also interesting to see how the experience levels are. Yeah. So I just, then I start sharing my screen and we get right to it. So share my screen. Just a quick sign if you can see what I'm presenting.
Yeah.
Perfect. Okay, yeah, so thanks for the kind introduction. I was asked to give an overview of natural language processing for beginners who maybe haven't been in touch too much with that topic so far. And natural language processing, I must say, is a very, very broad topic, and the boundaries are maybe sometimes a bit blurry. So what I try to do is to give here like an overview of the main tasks that natural language processing can solve. This is not an exhaustive list. It's much bigger than that, and it's as you probably can imagine, it's an evolving field, and many new models are coming out basically every day or every week. But yeah, let's see. Not everything that I will present here I will go in depth because it's going to be way too long. So most of the tasks that I will present here is just to give you an idea what's out there. But if you maybe then want to take it yourself and dive a bit deeper, then obviously you're welcome to do that. But there are 3-4 topics that I would like to look a little bit deeper into. All right, but first of all, I think it always helps to see it from a bird's eye perspective. So like in context to artificial intelligence, etc. So do you also see my mouse when I move around? Medha, can you confirm?
Yep.
Yeah?
Yeah.
Okay, perfect. Good, then I can use it as a pointer. So artificial intelligence, I think that's a very dominant topic these days, and but often it's being a bit confused where the difference is between artificial intelligence and machine learning. Something maybe like as a simple rule, machine learning is the part of AI that has self-learning models. So they have some kind of training data, and they along the data they can learn themselves to solve certain tasks, problems, etc. The part that is not self-learning within artificial intelligence is something like like an expert system where an expert has written down certain rules, information, and you can retrieve it. So like a database or some statistical inference can be part of that. Within machine learning, we have neural networks. So neural networks is the field where we start to solve more complex problems, such as identifying objects and pictures, creating images, but also with the natural language processing that I will get into in a moment. And often neural networks equals deep learning, but because we have in neural networks, we have like these processing steps and multiple processing steps, then that's basically referring to the deep. But there are also shallow neural networks where it's not deep. So that's why here's a distinction between these two fields. And deep learning is really like the cutting edge of where we solve these harder problems. And I'm mentioning all of this because natural language processing is overlapping with all of these fields and much more. And there are like rule-based solutions for problems, but also like more sophisticated versions where we have machine learning involved, and then maybe deep learning, especially talking about recurrent neural networks, LSTMs, if these terms are making sense for you. If not, don't worry about it. There's a lot within this field. And actually the same is true for computer vision. That's it. Yeah, it's just as a reference here as well. What I would like especially to talk about are the tasks. So you see there are many tasks, and I try to cover like the most common ones here. So yeah, I will not go through all of them. We have for each one a dedicated slide, but some of them I will really skip because because it's otherwise it may be a bit too time consuming. But the ones where I think from my perspective, what I've seen so far, it's either redundant with some other tasks or partially redundant, or it's very rarely used because of it's just not so much in an application. The 4 tasks that I would like to dive in is language modeling, named entity recognition, part of speech tagging, and sentiment analysis. We get into this in a moment. Taking these tasks and mapping them on this slide here according to how easy they are to implement, and like how the implementation difficulty in general, from easy green to high difficulty red. It's mapped here, and against is it like semantically looking at text, because natural language processing is at the core, we are working with text, right? Also, when we have someone speaking in a microphone, then we have a video, then we have like some MP3 data that, and one of the NLP tasks is then to also translate it into text. So basically, text is the base of all of this, and we can look at it from the syntactical point of view. Basically, the grammar, yeah, the rules that languages have. And semantic. So what is the meaning behind the text? And this in this graph here, there's basically a mapping between, is it syntactic? Is it a mixture maybe? Or is it semantic? And on this axis, is it easy to implement or low implementation difficulty versus high implementation? And you can see that syntactically, so this is these are the rule-based approaches, or there are certain rules to take into account. They are quite easy to implement, yeah. And then when it's a higher, like a more difficult implementation, it definitely has a semantic part. And mixture also means it has a semantic part, yeah. So basically summarization, as it says already, taking a big text, summarizing it into a smaller text. You need to know what is the sentiment, what is being meant behind the text. Okay, I also have to have the time in sight. Okay. So first of all, exactly, I would like to look into part of speech tagging. So just one more time, this X here represents all of the tagging and parsing, where we are looking in a more simplest, it's more like a simple task. Yeah, you have a text and you want to tag it in a certain way, identifying the nouns, the pronouns, adjectives, the verbs, adverbs, prepositions, conjunctions, interjections, and then labeling basically the words within a text. So here, this example is heat water in a large vessel. Heat, so it's to heat, yeah, verb. Water is a noun, and we have a preposition, adjective, it's a large. Vessel is also a noun. And this addition of the text, what is it good for, right? It is good for, this is one of the basic steps that we can do in order to achieve in order to solve more tough problems, such as text classification. In order to do a text classification, so with text classification, I mean, there is maybe like, let's assume we have like some kind of a issue ticketing system, and we want to know what the topic is that that is being discussed in the piece of text. Then we want to classify it. Is it maybe regarding our front end user experience, maybe some notifications of an app? I'm just saying it abstractly. And in order to classify it properly, we need to do some elementary steps, and part of speech tagging would be one of them. For instance, there are many others. So this, in its core, what part of speech tagging is, I also have this label deeper here because I would like to show it along code, and that's why I'm like switching the screen. I hope you can see it well. If you don't see it, then please say it. Otherwise, I just continue. And just one additional point for natural language processing in general, yeah, like solving many different cases, especially the ones that are sort of like straightforward to solve, like sentiment analysis is like still straightforward. Identifying the temporal text, that describes time, and that's sort of also easy in a text. But then identifying a meaning is again hard. But the easier ones can be easily outsourced by language libraries. Yeah, so we have Spacey, for instance, as one of them. Then we have NLTK. There is Fast Text from Facebook. And Genzim, for instance, that is famous for its summarization. There are very much libraries out there to use. Some of them are like leading in this field, which I would say spaCy is part of that. And yeah, so just to give you a glimpse of how this implementation could look like. So you would first install that library. That's usually a one-liner. Then you would import that library. You would load a model. So it's via spaCy. Maybe if it's too small, maybe I can zoom in a bit. That was zooming out. Okay, much more I cannot zoom in. So first we load our model. There are some pre-trained models that spaCy offers, very, very lean, with the .load button. And then we insert our text. So here would be doc. Yeah, we call it doc because it can be any kind of document, right? And our text is, Apple is looking to buy UK startup for 1 billion. So if we then, we basically want to take the token, so every single word here, yeah, we want to print the token, and we want to print its lemma, what we do in a pre-processing step, how it looks like. We lemmatize it, we make it, we shorten it down to its stem of the word, and then we perform our part of speech tagging. Yeah, exactly how exactly how we have done it here. We link a specific, we tag a specific, what was it called? Yeah, the nouns, pronouns, part of speech. So, and then you can run it here. For your code, you can just, oh, please reload and try. Okay, this can take like a minute, so I just come back to it in a moment. In the meantime, I just go further. But this is part of speech tagging, yeah. Can be very helpful. Other kinds of tagging is this combinatory category grammar tagging. It's a bit more fine-grained. I will skip this, but it's the same category. Shallow parsing, basically also, instead of like saying what noun, what is verb, it says like full parts of the text. Yeah, verb, this is the verb phrase, this is the noun phrase. Then we have conference resolution as another topic in NLP, where, for instance, we have a text like this one: IBM rises after the iconic software firm posted stronger than expected fourth quarter earnings, and so forth. And what it does, the conference resolution, maybe the name is a bit too fancy for it, but it takes the name and tries to identify within the rest of the text what refers to actually IBM. So the iconic software firm refers to IBM, right? And this is the task that is being solved here. Yeah, and like if it's, yeah, don't get overwhelmed with all of the tasks that I'm going through here. It's you don't have to worry too much about it. It's just to give you really like the big picture, bird's eye perspective of NLP. Then we have constituency parsing. I just skip it for now. Basically like creating trees of the text. Dependency parsing, where is the root of the text? Yeah. And named entity recognition would be the next one to dive in. But before we do that, I just go back here, and it has run. Yeah, it was, I can maybe show it again. It goes faster because we have loaded it again. And in part of speech tagging, as I said, we have the text, the lemma, and the pause, the part of speech. So it prints out the apple. The lemma of apple is apple, because it's, yeah, there's nothing to lemmatize, nothing to shorten. And it's a, yeah, proposition, or no, yeah, pro PN. I don't actually know right now exactly what it refers to. Yeah, this is yeah, we like, it's a named entity, but this means something specific. Aux is a, yeah, the verb. Okay, I go more to the ones that are clear to me. So looking, it takes the word looking, it stems it or lemmatizes it into look. Yeah, so all the versions of looking, we are not interested in that. And then it says, okay, it's a verb. Then we have here verb again, here nouns, symbol, number, billion is even, is a number as well. Yeah, and this is basically the tagging of what it refers to. And as you can see, 2 lines of code, maybe 3 lines if you take this one as well. Next was the named entity recognition. Named entity recognition, as the title says, it tries to recognize the named entities. So that's what this one means. Prop N, it's a proper noun. Yeah, proper nouns, locations, dates, names, other dates. So it tries to identify all of this within a text. This can be super helpful for more complex NLP problems. Again, I would like to show within Spacey, maybe I need to just run it again. Yeah, no problem. How is it looking? Again, we load the same model. We don't even have to be specific or anything. Like it's really just the same model that is capable of doing that. We include the same text again. And then what we want to say is we just say end. So within all the entities in the text, we look at the text itself, the starting character, the ending character within our text, and then which label does it have? So which kind of entity it is. Yeah, so here Apple, we're from 0 to 5, and it's an organization. UK is here, 27 to 31. It's a geopolitical entity. Yeah, makes sense. $1 billion is money. So with this, we already have a very valuable tagging of the text. And I was in a bigger project involved last year where we tried to orchestrate a lot of documents. We had a lot of documents within the organization we were working in the oil and gas industry. And so they had really like hundreds of thousands of documents. And all of these documents were discussing geological positions and sandstones and whatever there all is to find. And what we have done is we have parsed all the text, have performed a named entity recognition, and then put this named entity recognition onto a knowledge graph, so that we developed a search, like a company internal search engine, to identify in which paragraphs are they talking about this sandstone or that geological object, etc. So that was very helpful, and this is named entity recognition was playing a major role here. Okay, I continue. Temporal processing, as the name says, it tries to identify time mentions. Yeah, so next Wednesday, we know exactly which date. Last year, we know 2016, or now it would be 2020. Taxonomy learning. It is one of the tasks that can be done, but honestly, I haven't used that. We didn't see the need yet to really implement it, so I wouldn't give it too much attention here right now. Semantic role labeling. Actually, we can also skip that, but it says which is the agent, who's the recipient, and what's the theme about it. Semantic role labeling aims to model the predicate argument structure of a sentence and is often described as answering who did what to whom. Yeah, can be definitely as well interesting. Entity linking is similar to named entity recognition, except that to the entities that are being found, we link a knowledge base. Yeah, so it can be a link itself, here Wikipedia, for instance, but it can also be like some database that we have, or some document. That doesn't matter. Here's all the everything is possible here. Another one is relationship extraction can be done with NLP, where we give a text to our NLP model, and it can extract from the text that Tabasco recipe originates from Edmund McIlhenny. So you see here Tabasco, then there's one sentence that finishes, and then in the second it says the recipe originating from Edmund McIlhenny. Yeah, so this is another task. Valuable information for sure. There is not much difference between relationship extraction and prediction. Here we basically say, okay, what about Roman Jakobsen, Moscow, and then along a text, the code predicts is born in, for instance. What is the relationship between these two entities? Okay, but that's all, more or less all in the same direction, so I try to continue. Then we have semantic textual similarity. These are, please don't get confused by the words too much. It's they try to be very precise here with what the task itself can do. So what we do here is semantically means the meaning, right? And textual similarity. So what is do they have the same meaning, two texts? So if we, for instance, compare how are you with how old are you, this is not the same, right? These are two different questions or two different meanings behind this text. But if you mean how old are you and what is your age, the answer can be slightly different, but the meaning behind it is still similar. Not exactly the same, but similar. And this is what this task tries to do. And obviously we could like now go into every single task and look on a code perspective, and then how this is being maybe resolved, these kind of problems. But I think this would be maybe, this would definitely not be feasible in this overview format that we have here right now. All right, lexical normalization, here we have tomorrow, so there's like some misspelling, and to transform it into pics into pictures, coming like allowing some errors and then normalizing the text into one specific text. This can be helpful for certain applications when you want to see if the text is actually the same or close. Like, we can delete one text because it's basically they're talking about the same, and we don't need to have a double, or I don't know. But this normalization or the transformation into one normalized version of a text makes often sense as an elementary step. Okay, I need to now hurry up a bit. This is word sense disambiguation. Again, maybe a bit a complex word, but it's the meaning behind it is super simple. The sense behind the word, we want to disambiguate it, so we don't want to have different kind of meanings. For instance, for sea bass, we can have three kinds of meanings. It can be a type of fish, there can be tones of low frequency, and it can be a type of an instrument. And in order, like, we want to along the text, the context that is with that word attached, we humans, we know what is now being talked about. So I went fishing for some sea bass. Then it's clear, okay, they mean the fish. But for the it's not a standard resolution for NLP code. So this needs to be taken care of. And obviously, like, it's very important for like classifying texts, etc. Grammatical error correction, this is it's closely related with that normalization that we've talked about, or can also be helpful in terms of if you know that application grammarly, for instance, that where they suggests you corrections. Textual education, I have talked about that already more often. So it's the core of it is taking a text, and then we have certain categories, let's say price, product, service, location, and what is the probability it belongs to it. And here it's the highest probability it has. It's here it's 7%. So this is not too normalized here right now, but the highest probability is they are talking about a product here. Yeah, and this can be obviously this. There are many ways to achieve that, but how I would do it is maybe I would perform a couple of elementary steps like part of speech tagging, etc. I would vectorize it, the tokens, the single terms here. I would put them into vectors and then use perhaps a support vector machine or something to really classify in what category it does belong. Yeah, or it can be also done with more sophisticated algorithms such as convolutional neural networks or recurrent neural networks. Okay, yeah, deeper language modeling is an ongoing research since a long time, but it has been very like dominant in the NLP news lately, because there are many models that are achieving outstanding results because what they are now doing, and with them I mean the Googles. I think also in China, I'm not sure if it's Tencent. No, I'm not entirely. No, not Tencent. In China, they have also developed like a big language model where they have billions of parameters, and one of them that was very dominant for me, at least, was the GPT-3, and GPT-3 is super interesting because it can solve a lot of different problems. It can generate. So maybe quickly back to the slide. What it does, you can give it a text, and it continues the text. Yeah, it continues it. So it generates text. And looking at GPT-3, it has a lot of beautiful side effects. For instance, it can become an author of poetic language, but it can also be a blogger. Maybe I can like quickly show what it has written. Let me zoom in. Yeah. So here's an example. This is what a GPT-3 has written. Yeah. So and here the mode is being a blogger. So there are lots of posts for GPT-3 to study and learn from. The forum also has many people I don't like. I expect them to be disproportionately excited by the possibility of having a new poster that appears to be intelligent and relevant. I've been following the forum for years. There are many posts I know the answer to, so I could provide a quick response and measure how well GPT-3 does with comments similar to those I make. The sense behind it is maybe like, what is he trying to say? But it is like as if someone has written it, like a human. And there are many other examples where it's really indistinguishable from a human. It can generate cooking recipes, yeah, Hawaiian pancakes, prep 5 minutes. So you let GPT-3 train over many different recipes, and then you say title, for instance. Yeah, I'm not exactly sure how they've done it, but a logical application you just type in Hawaiian pancakes, a recipe for Hawaiian pancakes, and then it generates the rest. And they actually make sense? Chop the banana, slice the tomatoes. Yeah, it doesn't make too much sense. Yeah, prep 5 minutes, cook 20 minutes, difficulty easy, makes 12 pancakes, and then peel and roughly chop the bananas and slice the tomatoes. It doesn't make sense, but grammatically, and if someone would tell us, we would think, yeah, it's a human, but he's a bit confused. yeah, maybe we can also share this link to just get a to get basically more ideas here. Okay. Medha, if I'm in the last 5 minutes, you can let me know. Yeah, then I'm wrapping up in time. Yeah, machine translation. I think that's quite obvious. Google Translate. Yeah, it has been like the performance of Google Translate itself. There are many others, of course. Is really good. Summarization, I've said that already, that summarization, having a big text, putting it into a smaller text. There are two kinds of summarization. Is the extractive summarization, which is a bit more simple for achieving like some results here, because you just basically take a text, like some key sentences of this text, and maybe adjust it a bit. An abstractive summarization is a bit harder, because you really want to get to know the semantics, the meaning behind this text, and want to like put this, paraphrase basically what has been said in the text. Information extraction is also one of the tasks. So here we have the sentence, Barack Obama was born in Hawaii. So we have now two pieces of information. Barack Obama was born. This is one information. I mean, it's quite obvious for us, right? But in the text, this is like one information, and the other information is Barack Obama was born in Hawaii. Yeah, can also be a great addition to more sophisticated natural language processing tasks that you want to solve. Question answering, we go now into the direction of chatbots, but maybe also yeah, bigger sophisticated language models such as GPT-3. Common sense, the same. Yeah, context. We have Paul tried to call George on the phone, but he wasn't available. And then the question could be, who wasn't available? The answer is George. It's very similar to question answering, but yeah, it's here in question answering we can have many different answers, and here we really try to also boil it down to one simple answer. Dialogue, yeah, I skip it for now because it's quite obvious, I think, for natural language processing. And then natural language inference. This is interesting maybe in the research field, or if in politics or something. What is happening with natural language inference is that we have a basic text. Yeah, this we call the premise, and then we can formulate hypotheses to the text. For instance, the recipe originating from Edmund McIlhenny in 1868 has been used by the McIlhenny family for nearly 150 years. Here it says neutral. It's like, maybe we want too much, we cannot falsify, we cannot verify what has been said here because it's not written here. Yeah, but we can say Tabasco is made in the US because it says here Avery Island, Louisiana. So this hypothesis is true, but the hypothesis is also false. This one here, because it says is made in California, and it's not made, it's in Louisiana. So basically we can probe an original text with different hypotheses. And as you maybe already can feel here, we need sophisticated language models in order to do that. This cannot be done with just some tagging or some entity recognition or so. So it needs to be like a more sophisticated language model that has been trained with large amounts of text. Now maybe even going a bit outside of the computer, or not just looking at text, but additional things, and peripheral input, automatic speech recognition. So you talk in a microphone and it is being translated into text. There are many APIs that can solve that problem for you. Yeah, also like Google is offering like very officially like with good performance some of these tasks in when you watch YouTube, for instance, then there's the CC button. This is basically exactly doing that. It takes the audio, translates it into text. Sometimes it's not perfect, but sometimes it's surprisingly good. So this is what this task is all about. So we are right now on page 33. It's not much left. We're like we're almost done with that, and then I'm happy to answer questions as far as I can. But I would really would like to just finish the high fly above all the tasks. Another one is semantic parsing. So semantic, the meaning, yeah. We have a text, and then it basically in this task, we transform what the employee has set into SQL code here, yeah. So basically into database code. So what are the total sales of Tabasco in 2018? Then it summarizes all the total sales and gives it out for the year 2018. This is another application that exists. Okay, and this is the last deep dive in sentiment analysis. As the name is very suggestive, as always. That sometimes could be confusing, but here it really tries to analyze what is the sentiment behind the text, right? I went fishing for some sea bass, which is my favorite seafood. So that's positive because we have a positive word. There are simple solutions to that, meaning we just count positive words. We have a library or like a table with positive words, and we have a table with negative words, and we count the positive words, we count the negative words in the text, count them again, count them against each other if it's above 0. So the positive ones are +1, the negative ones are -1. If we are above 0, then it's a positive text, or yeah, if it's like a lot of positive words, then it's a very positive text, and the same in the negative field. But I also would like to, I think, give a little intro here on via Spacey. But maybe one before we go in here, this was a simple approach that I was just now explaining. There's also a more in-depth approach that really like takes the content and tries to also find the with a more well-trained language model. We try to find the maybe what's in between the lines, yeah, because this is like in between this is like a very explicit, yeah, favorite, or I like that, or this is like very explicit counting. But implicitly in the text, when I, for instance, say I'm very happy that you haven't cleaned anything today, then it's implicitly, and we might understand that it's sarcastically meant, yeah. And actually we criticize that nothing has been cleaned. Obviously, here comes also like a cultural component, but language models can also capture certain cultural things, cultural like information. With Spacey, again, we have like sort of a simple, very like we can outsource that task very easy into Spacey. We just have to import the libraries. So here it's called the Spacey text blob that we need. Then we load again the model that we know, and for English, the core model, and then I think trained on the web, SM, I'm not sure. And we add a pipe, that's the Spacey text blob that we need to add. But yeah, we don't need to question that too much. It's just taking our model and putting it into a pipe with many different steps. That's basically what's behind it. And then we we define the text. Here it is. I had a really horrible day. It was the worst day ever. But every now and then I have a really, and then I cannot Yeah, I have a really good day that makes me happy. Yeah, and so then we use our model, the NLP model, and paste the text. And with these, we can say what the polarity is. So what is this? That's actually what the sentiment is. Here the sentiment is minus 0.125, probably because we have really horrible, yeah. Looking at the assessment, we have really horrible, 2 times minus 1. It was the worst, yeah, worst is also, and exclamation mark is both being taken into account. And then I had a really good day. I have a really good day. That's something positive again at the end, and happy. And it takes it into account, calculates it in a very straightforward formula, and gives it a polarity. Yeah, exactly. And subjectivity, and this is like an additional parameter that is being calculated. How much is it talking about, like from its perspective? So it was my worst day. I have a good day. It's the subjectivity here. Yeah, and this is just, I just want to like show that in order for you to maybe see how easy it can be implemented and then used in a bigger application. I think this is the last one, standstill detection. How much is a text in favor for one entity? So here, Donald Duck is much nicer than other rich ducks. Other rich ducks is Dagobert Duck, I guess. And this one is, it has a stance, so it has a stance towards Donald Duck. Yeah, more than to Dagobert Duck. This is what this task is all about. Domain adaptation is not so important. Like it's obvious. If we talk about the automotive industry, that's something else than about the shipping industry. Multimodal emotional recognition is taking. So multimodal is taking maybe we have the text on one hand, but then maybe we have a camera that looks at the face, does some complex identification. Is that person smiling? Is the person angry? This can be detected with computer vision applications quite, I wouldn't say easy, but this is a solved problem in brackets. The same with body expression analysis. Is a person yelling, or is there like some other like something else that can be identified in the voice? And then physiological signals can also be included as an additional mode. So meaning an elevated heart rate, for instance. Yeah. And taking all of this into account gives us a better, puts us into a better position, including the text, because this is all about natural language processing, gives us in a better position to estimate what the sentiment is, what the emotion is of a certain language, the emotional state. This is a super interesting topic and also ongoing research. Multitask learning is doing multiple things at the same time on a text. And that's it. Yeah, exactly. So I'm sorry if I took a bit too much time, Medha, but
No worries.
yeah.
Martin, if you could just move to the next slide, I think.
Yeah.
Right. So thank you all so much for listening so patiently. And it was so wonderfully explained, Martin. I really didn't want you to stop. It was through each example that you explained. I think I had a very different understanding of this topic altogether. Thank you so much for taking it so beautifully. For all of you here, this session was powered by upGrad. We are online higher education provider across the globe. We've got learners from 85 plus countries, and we have successfully impacted 2 million lives. So we provide courses in data science, machine learning, management, software development. The ones that we have on data science are partnered with various universities. The ones you see on the screen are LJMU, which is Liverpool John Moores University, which is based in UK. It's a 20-month program. It's a Master of Science program. The one from University of Arizona is a 24-month-long program, which is a US university. The one from IIM Kohikor, which is a leading school in India, is one on data science for business decision making, which is essentially for all decision makers who need data science. If we move on to the next one, there are the machine learning courses that you just heard from Martin, which is NLP is taught as a specialization in both machine learning and data science. And we've got machine learning as a topic from LJMU, from IIT, from Triple IT Bangalore. It's a great university in India. There's the 3 rungs that you see on the slide are certification, executive program, and masters. So for different needs, we've got something for every one of you out there, depending on how much in depth you would like to get into the program. So that is a very short overview of all the programs that we provide. I will, because we've got about 10 minutes left into this session, I will go on to take questions from all of you. I think one question from Ram Kumar was that companies are recruiting only the experienced people. For internships, companies are paying less or no salary. What should one do? So all the programs that I just mentioned to you, Ram Kumar, have live projects included as a part of the curriculum. So it's not just recorded content, there's a lot of live learning involved as well. And the projects that you do here can be incorporated as a part of your GitHub profile. Now, this GitHub portfolio is what you use to present to your prospective recruiters. And that essentially becomes your tool, even if you don't have an experience, right? You don't need to especially do internships. You can use these projects to show that you're a capable candidate, you have an understanding, and you can move on from there. So that was an answer for your question. There's also a career opportunities portal at upGrad, which you can utilize to then see which are the jobs available at the end of the program. This one's for you, Martin. Jairus is asking, how does the system deal with sarcasm? A statement like, yeah, right, you're excellent, your customer service was excellent at screwing up. How does text analysis deal with something like this?
Yeah, that is a good question, and it's really not easy to solve that. This can, I think the only, if we cannot identify, so first, if there is, oh, the slides are gone for some reason. Okay. Okay. So when we have a certain problem that we want to solve with NLP, then first I would like to see what are the simple, more rule-based or closer to the rules based pieces of NLP that I can utilize for solving that problem. And looking at the text, if it says I love your customer service, but it actually sarcasm, then we cannot. Sentiment analysis would give us wow, great customer feedback, or like good, this is very positive. So first of all, we need to have a more sophisticated, bigger language model that is being trained, and it's also trained on the specific informations that maybe it needs to have like an additional mode. So maybe the number of stars that has been given. If we have just 1 star and it says the customer was great, then we need to train the model that this is actually a negative expression. But it's natural language processing models can also be confused as we humans are. They are not better than, they cannot be much better than we are, right? So if someone tells me, hey, you did a great job, and I actually and I maybe think I have done a good job, then I think, oh, that's a compliment, but maybe that person has something else in mind, but I cannot know that. And language models can also not pick up everything. Yeah, we need to take all the information. Like these models are the better, the more information then they can take into account. Yeah.
Great. Thank you for answering that. If two sentences are combined, would it treat it as the same? How old are you and what is your age?
Sorry, could you repeat that question?
So Mayank's question is, if two sentences are combined, would it treat it as the same? Essentially, if it's asking the same thing, how old are you and what is your age? So does it treat it as,
Okay, yeah. I mean, it depends. It's probably related to one of the tasks that I've shown, but I know which task. It's related to the one, the semantic similarity.
Right.
Yeah, to the semantic similarity. How old are you and what is your age? Yeah, it's semantically very similar. So it depends on what we want to do with that. If this is as an input into maybe a bigger model, then we don't want to double weight that. Yeah, then we can just drop one, or yeah, exactly. So it depends what we want.
Sure. Sure. What's your vision of what's better, ML or NLP? Is one question. And what's the difference between NLP and computer vision? I mean, you can choose to pick up either or both.
So the first question is, what is better, NLP versus ML?
Yeah.
I mean, better, you cannot say it. It depends, like you have certain things that you want to do. Yeah. Machine learning is, yeah, you cannot say the one is better than the other.
So, Ramkumar, to answer your question, both have immense opportunities up there. If you just look at the number of jobs available in the global market for each of these, you will find that both of them would give you an equal number. So I mean, it depends on what you want to choose, and definitely take your time in deciding what's better for you. Reach out to us at admissions@upgrad.com, and our admissions counselors will help you based on your current profile, based on what your future career goals are. They would definitely recommend what's better for you. The second question was difference between NLP and computer vision.
Okay, yeah. So NLP is basically what I just described, everything like regarding text, processing text, also natural language, so how we speak, and maybe extract information, etc. from that. And computer vision is when we have a setup with a camera, and I'm now here in the camera, and then it tries to identify objects. This is one task of computer vision, identifying objects. So it will then try to identify me. Yeah. So it would basically try to identify this that I'm showing here, like this border, and it would cut me out, like it actually does with you right now, Metha. This is object identification. Yeah. Exactly. This is one task of computer vision, and there are many other ones. There are really, really great achievements in computer vision, like for instance, identifying cancer in medical images better than some doctors can do, and definitely faster, because it's just one button. It scans it, 1.5 seconds later we have the result, and even the performance is nowadays even better.
Interesting you brought that example of medical application, because Harish's question is, are there domain specific NLP models? Because medical professionals' technical vocabulary would be different from somebody who's working in finance or as a management consultant.
Yeah. Okay, here's a poll right now. Okay. Great.
Yeah, that's for all of those who started the like the session, etc. You can.
Perfect. So the question was like, what other fields, what fields are out there, yeah, for NLP?
Right, if there are domain-specific NLP models, because each sector could have a different technical vocabulary, so you might have to train accordingly, right, to be first able to understand the term.
So these models are very valuable to companies. So when there are very well trained, like I'm speaking about like very well trained domain specific models, I don't think they are open source and you can download them and use them. But there are some demo models when it comes to bigger language models that you can use, yeah, just to showcase what they can do. But professionally speaking, we have also developed like a big language model for the oil and gas industry. And the performance you can achieve with a very, very specific language model and corpus. So that means the text that you have as your training basis. And this is unparalleled. Like this is you can really achieve outstanding results with very specific data sets or corpuses. Yeah, and I assume for everywhere where we have NLP projects going on, domain specific, that there are companies that have these trained models for themselves. Yeah.
Great. And that brings us to the end of this session. Thanks so much, Martin, for answering all these questions so patiently. I understand there are a few more questions, but as I'd already written in the chat, we're slightly crunched on time today with Q&A. But I hope Martin's wonderful explanation clarified a lot of your queries already. And a few of you are still left to answer the two questions. If this session was, if you found the session valuable and if you would like to receive communication from us for future sessions. With that, Martin, thank you so much for your time today. And for all of you who attended, thank you so much for your time and patience. Look forward to having you again for another exciting session.
Thank you very much. My pleasure. I really appreciate it.
Have a good evening. Good day.
Good day.